Okay, today what we're going to do, guys, is kind of pull together everything that we've been doing. We're going to look at tables, equations, graphs, and we're going to start interpreting them and comparing them. And we're going to do those based on what we talked about last class, which was a unit rate. So really the big focus is, how do I take all these different forms of looking at things and figure out a unit rate from each of them. So if I have a table, the way I find my unit rate, the value of the first column when the second column is 1. So basically I want to make that second column, whether it's up and down or side by side, when that second column's a 1, whatever that first one is my unit rate. In a graph, what I need to do is find where x equals 1. I'm going to go up from that point until I hit the line, and then I'm going to go over to where the y value is. Whatever that y value is tells me what the unit rate is. If I have an equation, the equation, guys, is always written as y equals some values constant times x. So if I want to find out what the unit rate is, I substitute a 1 in for my x, multiply it by whatever constant is there, that gives me my unit rate. Okay? So we'll get to practice on all three of those, but basically understand that's the way we're doing it. What we're really doing is looking for my y when my x is 1. If we're doing common unit conversions, what we're going to do on these, and you're going to do some more of this one today, actually, really quickly, open up in your agendas to page 108. In your agendas. The school has actually given you guys a cheat sheet. You probably didn't even know it. Nope. So, page 108 in your agendas. On top of the periodic table, what do you see? What about them? Those are your unit conversion charts, guys. So, if you're unfamiliar with any of the units, this chart has most of the units that we'll be using in class. One piece of good news for you, when we do tests and quizzes, we will make sure that any conversion units are very well posted and that you will know where they're at. So here's the deal on this. The first thing I'm going to do, write down what I'm converting. Okay? Then I'm going to multiply by the conversion factor. So let's say, for example, I wanted to change 36 inches into feet. So I write down what I'm converting, which is 36 inches. I then go into my chart and I look for the conversion factor between inches and feet, because I want to get to feet. So the unit I'm converting to goes on top. The unit I'm converting from goes on the bottom. Looking at my conversion chart, what's the relationship between inches and feet? Or you can just tell me if you know. 12 inches is 1 foot. So now that I've got feet and inches already written, all I do is write those numbers in. 1 foot, 12 inches. Okay? To multiply, that's going to go over 1. I have inches on top and bottom. Those erase out. So 36 divided by 12 means it is 3 feet. So 36 inches equals 12 feet. Literally that simple, guys. You'll just write them down. I write down the one I'm converting. I multiply by the conversion factor with the unit I'm converting to on top. Both numbers on top, I would have multiplied, but they're not. I have one on top, one on bottom. That means I divide. When I write my answer, do not forget the units. If you only wrote 3 and left the feet off, you would only get half credit at most. Okay? You must include your units. Questions on the notes? Okay, you guys may want to write down that example, because that's one of your examples you'll get for today. Yes? You do what? Are we doing what? Yes. Conversions is something you guys will literally be doing your whole lives, so this is one you definitely wanted to get down. Okay, go ahead and open up to page 79 in your modules. Page 79 in your modules. Guys, make sure you're looking at the top numbers. You want 1 because we're in module 2, not 2 or 3. I've seen people that are flipping to the wrong sections. So module 1, page 70, what did I just say, 9? Yeah, page 79. Okay, and our first one, we've got the ratio of cups of blue paint to the cups of red paint is 1 to 2, which means for every cup of blue, there are 2 cups of red paint. In this case, the equation would be red is 2 times blue, or R equals 2B, where B represents the amount of blue paint, R represents the amount of red paint. Make a table of values. That's all we have to do on this. So the first thing I need to do on my table is labels. So we're talking blue and red, listed in that order. So I go, B is blue in cups, R is red in cups. Oh my goodness. What is this stuff, guys? Have you ever seen that before?
No. Yeah. I've seen on my dog.
Because I graded all my science tests, and I was absolutely shocked at the number of people that didn't realize that was a required thing.
I did it. I did it. Oh, I did it.
I hope you did it. Okay, guys, so look at this. What's my first entry going to be, Cameron? So what goes under the B?
1.
What goes under the R? 2. Okay, what's my next entry going to be? Ready?
2, 4.
2, 4, how'd you get that? Okay, so you're looking at it from a multiplicative. So let's keep the multiplicative. So our next one's going to be times 3. So it's going to be what?
6. 36.
3, 6. Then I'm going to do times 4, and it's going to be 4, 8. Then I'm going to do times 5, and that's going to be 5, 10. Guys, don't forget to show your work. Another major failing on our test. And just as a side note, guys, we'll be giving your test back on Wednesday. We weren't sure we'd have classes on Tuesday when we left on Friday because it looked like we were going to get hit by that typhoon. So we decided we weren't going to give you guys it on Monday and wait till Thursday. So we decided, we made the call. Wednesday, Thursday, you're getting those back. So you'll have 2 weeks once we hand them back to you. But you'll get them on Wednesday. Mary?
Do you have to put how you showed your work on the bottom?
No. Great question. Mary said, do I need to show how I did my work on the bottom? If you do additive, you do, but that's also why we only make you do 2. But when I'm doing multiplicative, I'm doing them both by the times. So if you want to write it twice, I wouldn't count it off, but you need to at least write it once. But if you're doing additive, then I would have done it on top and bottom. Okay? Okay, next one, Mr. Sybil's a librarian who really enjoys reading. She can read 3/4 of a book in 1 day. This relationship can be represented by the equation. Days equals 3/4 books, which can be written as D equals 3/4 B. B represents the number of books. D represents the number of days. Okay, they didn't give us any additional instructions, but we're going to assume we're just making a table of values. So, what's the top, what's the bottom? What are we going to put in? What do you think, Mary?
B equals books.
Okay, and which one goes on top? Why?
Because she can read 3/4 of the book.
Okay. You were doing so well till you got your explanation. The reason, guys, is because of how it's written. 3/4 of a book, 1 day. What came first? Books. So books is written first. Also, we can look at our equation. Remember, D is the same as my Y. Y always goes second. So whichever one would be by itself would be going on the bottom. So what's my first entry going to be? Hey, Brayden.
B is 3 and D is 4.
Oh, I don't like that.
4.
What did it say, guys?
Oh.
What do you think? Awesome. I like that a lot better. So B is 3/4, D is 1, because it's 3/4 in one day, right?
Yeah.
So what's my next entry going to be?
So, it could be 6/4 or 6/4.
How did you get that?
I added.
You added? Okay, so you're looking at it from an additive standpoint.
Or
So 3/4 plus 3/4 is 6/4, or 1 and 2/4, or 1 and 1/2. On the bottom, I'm adding 1. That makes it 2. So now we've established our pattern. So now it's going to be plus 3/4. That gives us 9/4, or 2 and 1/4. And then plus 1 is going to give me 3. So we'll finish the bottom because that's easy, 4, 5. So adding on the top gets me 12/4. 12 divided by 4 is 3. So there's the entry that Braden wanted to start with, isn't it? So we did see that, but that was actually on day 4, not on day 1. And then our next one, we got 15/4, which is 3 and 3/4. Is there anyone who is not comfortable with turning these improper fractions into mixed numbers?
Oh, no.
Really? Okay, they're really quite simple. All I do is I say, how many times will 4 go into 15? Without going over. It goes 3 times. Then I say, how much is left over? 3, because 3 times 4 is 12. 50 minus 12 leaves me 3 left over. So that's 3 and 3/4. No problem, Haley. Thanks for asking the question. Do I need to do anything else on there? Yes.
So when you get points for the dots, you don't change them into these numbers.
Depending on what we're talking about. Normally I want my answer in mixed numbers, but if it's like in an equation, it's okay to have an improper fraction in an equation. But normally for your final answer, you want it as a mixed number. Okay, let's go ahead and go to the next page, guys. Oh, I skipped one. Go to page 80. Yep, page 80. Okay, we got Brian and Shanice are both training for a bike race. Want to compare who rides at a faster rate. Both bikers use apps on their phones to record time and distance of their rides. Brian's app keeps track of his route on a table. Shanice's presents the information on a graph. The information is shown below. So far we have his information. So we get into the question, at what rate does each biker travel? That's what we want. Then explain how we arrived at our answer. There's kind of 2 parts to this. So in our first part, we need to break these down into rates or unit rates. So my first entry, now let's talk about what we've got here for a second. We've got hours and miles. So do we normally say hours per mile or miles per hour?
Miles per hour.
Miles per hour. So this is one we're actually going to flip it upside down. We're going to put the Y on top. So zero's not going to tell us anything, but if I look at that next entry, Brian did 75 miles in 3 hours, right? I want a unit rate. Anytime we're talking to unit rate, guys, I want that denominator to be a 1, right? So if I want to compare to 1 hour, how did I get from 3 down to 1? What goes in my magic box? Divide by 5. Awesome. So 75 divided by 3 means he has 25 miles per hour. Now, here is the beauty of graphs, guys. Graphs are super nice because I can pick any number I want to and figure out what my rate is. If I want a unit rate, that means I want it for every 1. So if I go up from 1, how many miles did Shanice go? 15. And guys, this is literally all the work you have to show if it's on a graph. Just show me where you went up. Okay, so what rate does each biker travel at? Brian travels at 25 miles per hour. Shanice travels at 15 miles per hour. For Brian, I simplified from 75 miles in 3 hours. For Shanice, I found the number of miles in 1 hour. So I apologize for some of the sloppiness in the writing where the board cuts out. That's miles. And that's 75. I think most of the rest of it you should be able to read okay. Okay, so that's all we're doing on those. Again, graphs are really the easiest because literally all I got to do is go straight up from the number that I need. In this case, it's a 1. So now on the next one, Shanice now wants to win the bike race. So I'm going to make a new graph to show the speed Shanice would have to ride her bike in order to beat Brian. So here's our task. We're making a new graph. So to make a new graph, what's the first thing I need to do? Hey, what? No. Hello? Title it. What do we want to title this one? Shanice's speed? I like that. That's actually one I like better than what A2 did. They just said bike race, but really what we need is Shanice's speed. So I think this is a more specific title, so I like that one better. Okay, what's the second thing I need to do? Lucretia would not matter because we're talking about Shanice. Dom? No, that's the third step. What's the second step? Michael? No, that's adding the numbers. We already said that one. What do you think? Labels. What are my labels? So I have my X and my Y.
X and Y.
X. Remember, X is always here, Y is always here. Is that all I need to do?
No.
No, I got to label what they actually are, right? So what's my X?
Didn't you say that the X and Y would be swapped?
Yeah. But I'm keeping it like they did it just for simplicity's sake. So what am I going to put on the X-axis? Hey, Michael. Hours. And the other axis gets? Miles. Okay. We don't need that much data, so I'm just going to go every 2. Here's another one I saw on the test guides. Remember, I said your intervals have to be equal, right? I had a lot of people that started at that first interval and then started skipping. Whatever you decide on that first interval, it's got to be for every interval. So hours, we're just going 1, 2, 3, 4, 5. Okay, now she wants to beat Brian. So what do you think I should do for my intervals on the side? What do you think, Big N? What should I do for my intervals on the side for Shanice if she wants to beat Brian? Brayden? Make what? Will 15 beat Brian? What do you think, Dom? 30? I like 30. Basically, any number I did above 25 would beat him, but 30 makes the math easier, so I like that one. Okay? Now, one I will give you guys credit for on the tests I graded, you guys actually did a pretty good job of actually using a ruler for drawing your line. So, let's ingrain that habit. Make sure anytime I'm drawing a line, I use a ruler. I again apologize that I can't do that for you up here because the smartboard doesn't accept the ruler, but do not just freehand this, guys. And there is a reason for that, because when I am doing a graph like this, I should be able to use this to extrapolate. In other words, I should be able to look in between these data points, and if I've drawn my line with a ruler, I know that that line actually hit right at that intersection, not down below it. So because I can't use a ruler, I can't really extrapolate on this. Okay? So there is a reason I'm being so finicky on using that ruler, but I should see that if I did a mile and a half, or an hour and a half, it would be 45 because it would be directly in between the two. So without that ruler, then my line's kind of wiggly and may not be as accurate as I need to in order to make extrapolations on my data. Questions on this page? I did like that most of you used the ruler. Almost everybody remembered the arrow. I think there was only about 3 kids out of my 130 I graded that didn't get the arrow point. There's only about 2 that didn't get it from the ruler. Okay, no questions. Let's go to the next page. Page 81.
All right, let's look at this next one, guys. Braylon and Tice both work. Still talking right here. Oh, no, I don't need to. Okay. They both work at a department store and are paid by the hour. The manager told the boys that they both earned the same amount of money per hour, but Braylon and Tice did not agree. They each kept track of how much money they earned in order to determine if the manager was correct. Their data is shown below. So here you go, Braylon. It gives you an equation where H represents the number of hours worked, and M represents the amount of money Braylon was paid. Okay, Tice right here is set up in a table. So the question that we want to answer, guys, is how much did each person earn in 1 hour? Okay? We need to know if that manager was being fair. If you and your friend work somewhere, right, Tice? Yeah. And don't you want to be paid the same amount as your friend? You don't? Oh, you want to be the one paid more. Oh, okay. But what if you weren't the one paid more? That wouldn't be right. Okay. Don't tell anybody that you get paid more, right? Okay. All right. Who do we want to find first? How much they get paid? Let's go with who? Tice. Let's look at Tice. Okay, here we go. Let's look at our table. How am I going to set this up? What am I going to do? Talk to us, Mary. Okay, so we want $34.50 because here's our money. And then we've got hours. Right? Okay, so he makes $34.50 in 3 hours. What am I trying to find, Mary? What am I trying to find?
How much money he gets
in 1 hour. My unit rate, right? How much per 1 hour does he get paid? So how did I go from 3 to 1? Divide by 3. That's my mystery box right here. So what is $34.50 divided by 3? We're going to 3 one time. I got my 4 one time. Ooh. How many times can 3 go into 15? 5. And then I put a 0. Where does my decimal go? I gave it away, Zach.
In the middle.
In the middle. Why? Why?
Because it's money.
It is money. Good reason.
And because you need something, because you have to divide it by dollars and cents.
Dollars and cents. And it's right here. Move it up. It's money. So how much does he make per hour? $11.50. Okay? $11.50. Okay. Now look right here. Let's go to Braylon. I don't have a table or a chart or a graph. I don't have any of that, Zach. I don't have a graph. I don't have a table. I don't have a chart. Right. What did they give us? What did they give us, Mary? Oh, wait. For what?
They give us the answer for free.
They did, pretty much, didn't they? They gave us an equation, but pretty much they gave us an answer. Look right here. Look right here. It says, Braylon was paid, M is the money, 10.50 per hour, right? So M equals 10.50. How many hours do we want to know?
1 hour.
1. Mary's right. So the money he makes is 10.50. Okay, so
Wait.
ties. M is the money. Do I need to?
No, you put N twice.
No.
Yeah, there's N 2 times.
Yeah, I redid it. Look.
Oh, I think
Because that's my answer, my flip. Because right here, guys, you plug in how many hours you want to know. Right here is where I could plug in hours. If I wanted to know 10 hours, I could plug in a 10 right there.
Oh, then wouldn't it be 8?
But I want, you know what? They wanted to use what? Yeah, it was H right here. H. How many hours did we want to know though?
10.
1. 1. So I plugged in 1. If I wanted to know 10, Michael, I could plug in 10 right here. Where there's a variable, I can always plug in a number. Okay? Okay. So Tice made how much? $11.50. Is that Tice?
Yes.
Yep. And then Braylon made how much? Right, Braylon made $11.50. 10.50, I'm sorry. Per hour. Right here, was the manager correct?
Yes.
No, the manager was not correct. Good, Zach. No. He was not correct. Why was he not correct? Oh, now see, you might be onto something there. No, he was not correct because Tice made $1 more per hour. All right, let's look at this next question. How much money, here's my question, will each of them make for an 8-hour shift? For an 8-hour shift. Okay, that's okay. That's okay. Let's just figure it out. Let's go back to the equation. M equals 1050H. That's Braylon's. How many hours do we want to know? How many hours, guys?
8 hours.
8. So I can put my little 8 right here. That means I multiply 1050 times 8. What is that going to give me?
Wait. What times what?
1050 times 8. What does that give me, Mark?
850.
How much?
$80.50.
1050 times 8. What does it give you, Chanel? Okay. So M equals $84. Okay. What about Tice? What is his equation? How much does he make an hour? Talk to us, Avery. So what's his equation? Good. So M equals 1150, and the hours we want to know is 8. So what's 1150 times 8? Talk to us, Angelo. $92. Okay. Guys, for those variables, you can plug in whatever you're trying to find out. I can plug in any amount of hours for that equation. Okay? Next one. Next one. Claire and Kate are entering a cup stacking contest. Both girls have the same strategy. Stack the cups at a constant rate so that they do not slow down at the end of the race. While practicing, they kept track of the progress, which is shown below. Here's Kate. Here's Claire. Guys, you're going to take your ruler and create your line. Okay?
So it's so satisfying. You have to, oh God, I'm trying to do the arrow. I'm learning.
All right. The question is, I'll wait till we're ready right here. The question is, at what rate does each girl stack her cups during the practice sessions? At what rate? What is it really asking us for? What is it asking us for? What, Mary? The, what kind of rate? Unit rate. Nice. The unit rate. Okay? The unit rate. Okay. We're not ready here, and we're not ready here. Constant talking right here at these two spots. So I'm going to push pause in just 1 second so you can get it together. Because I'm not going to talk over you, and I have a very loud voice. Okay. All right. Let's talk about Claire first. Let's talk about Claire first. What am I going to do? How am I going to find out? What am I finding? What am I trying to find? Mary's the only one that knows? What am I trying to find? The unit rate, which is what?
The unit rate of the stack cup unit second.
In how many seconds? If we're doing unit rate, it's how many seconds? 1. Good. There you go. Yep, you were right. Good. Per 1 second. Per 1 second. Now let's look at our graph. Let's look at our graph. Claire is easy. Kate is easy too. This one gives it away as well. Claire is easy. What am I going to look at? Yep. Yep. 1 second right here is how many cups?
5.
Okay. So what is Claire's unit rate?
5 to 1. 5 fractions.
Claire stacks 5 cups per second. Still talking behind me. All right, let's go to Kate. Kate, doesn't it pretty much give you the answer?
Yeah.
Okay, well, let's look. It tells you that, see, I'm going to underline it, circle it, amount of cups. C equals amount of cups. T equals time. T equals time, and that's going to be seconds, right? Okay, so C equals 4. How many seconds are we looking for? How many seconds are we? 1.
See, I'm learning.
You got it. You got it.
I already got it before you. She knows it.
Yeah. Good though.
But
But you're
it
learning.
doesn't matter.
So it doesn't matter. It's yeah to both of
It
you.
does matter.
It doesn't matter. Okay. So for 1 second, how many cups can she stack in 1 second?
5. Oh, 4.
4.
I think so he's the better one. Yeah. That's exactly.
So Kate stacks 4 cups per second. All right. Guess what? Kate doesn't like this. She notices that she is not stacking her cups fast enough. What would Kate's equation look like if she wanted to stack cups faster than Claire? What would her equation, her new equation, it was C equals 4T, which my time is second. What would it be?
Or 6.
That's not my equation, Courtney. Okay, good. Or S, whichever one. They use T, but I could see why you would put S for seconds, but they're doing the time in seconds, okay? Very good. Very good. Any questions? Nice job on that. Something fun? Why do y'all do half the things you do? I don't know, it's fun.
What do you want to do?
What?
Oh, so when you're doing this, that's just from here to here, we're just oh my gosh, you were really funny. Can't you just relate what
Yep. I think this is homework page. No. Okay, guys, this is your homework. Go ahead and tear out page 83 and also page 89.
Okay, on this one, guys. Everybody should be on 85 now. We're going to go back to what we were just doing, looking at unit rates to compare prices. So Vivi wants to buy watermelon. Kingston's Market has a 10-pound watermelon for $3.90. Farmer's Market has a 12-pound for $4.45. Which market has the best price? So they didn't say I had to do unit price, did they?
No.
No, but on this one, they're not going to ask it, so I'm going to do it to save myself time. So for me, Kingston is 10 pounds. I like to do dollars per pound, so I'm going to switch this one around. And do remember, guys, normally on unit rates, I want the dollars on top, but I wanted a unit rate, so I need to take this down to 1 pound. How do I go from 10 down to 1? What are you going to do, Handy? How do I go from 10 down to 1? Divide by 10. That's nice because dividing by 10 is easy. I'm just moving my decimal places once, so that's going to be 39 cents per pound. Then we have Farmer's Market. They are $4.44 for 12 pounds. How do I get down to 1 pound if I started at 12? What's in my magic box? Mary?
Wouldn't you also like find the common in between those things, like a common number that they wouldn't have?
You could. The easiest roll would be go to 60, but I know I have to find unit price, so if I'm going to have to do it anyway, I might as well do it up front. Rather than do double the work. So, how do I go from 12 down to 1, Mary? Dividing by 12. Okay, so this one we've got a little extra work to do. 444 divided by 12. As a reminder, guys, when I'm dividing by decimal, it goes straight up in the division bar. So 12 goes into 44. It's going to be 3 times. Gives me 36. Goes into 84 7 times. So that one is 0.37. I did see a few kids do this. Be very careful. If it's asking for cents and you're using dollar notation, don't change it to cents. Don't make the dollar sign a cent sign and leave decimals. Dom. Okay? If I'm using the cent sign, then it would be 37 cents. Cents actually goes after, dollar goes before. Don't ask me why, but that is the way they do it. So, which market has the best price? 39 cents or 37 cents?
37 cents.
Which is which market?
The farmers.
Okay, so Farmer's Market has the better price. Okay, what is the difference? Difference is what? What operation? Paul? Subtraction. What's the difference between 39 cents and 37 cents? 2 cents. So again, I'm going to use dollar notation, so that's going to be dollars 0.02 between them. If you use cent notation, it would be 2 cents. So you could write that either way. Just don't mix the two, guys. Okay, we only have time for a couple more you can do.
Yes, guys, let's move on. Mitch needs to purchase soft drinks for a staff party. He is trying to figure out if it is cheaper to buy the 12-pack of soda or the 20-pack of soda. The 12-pack of soda costs $3.99 and the 20-pack of soda costs $5.48. Which pack should Mitch choose? Which pack should Mitch choose? What am I going to do? Mary. So I'm going to put money and then the number in the pack. So I'm going to put $3.99 over 12, right? And then what? That's what I'm looking for, right? My unit rate. So I want to put 1. How did I go from 12 to 1? Divide by 12. Okay, so I'm going to say $3.99 divided by 12. How many times can 12 go into 39? It can't go into 3. I have to move over to 39. 3. Good. And that gives you 36. Okay? That subtract, that gives you 3. We're back to 39. Was in there 3 times, 36. Guys, it's going to be repeating, right?
The repeated that.
Or just keeps going. I shouldn't say repeated because this is going to be different. But it keeps going. So I need to do one more. Okay? 12 into 30 goes how many times? 2. 24, that leaves you with 6. Okay, I really am not concerned about that because, like Mr. Moore said, if we're talking about money, what do I round it to? What do I round it to? 33 cents, right? 33 cents. All right, let's look at the next one. So if I have 548 for the pack of 20, what do I need to do? I want 1. How did I go from 20 to 1? How did I go from 20 to 1? Divide by 20. So 548 divided by 20 goes how many times? Twice. Good. That's 40. That gives you 14. 148. That's too much. No, I mean that.
It's fixed.
Oh, is that what you're doing? Okay, 7. I heard 7. 7 times 2 is, or 20 is 140. Leaves you with 8. Bring down 0. What does it round to? 27 cents. Put my decimal right here. 27 cents. Okay? So what is the difference? Here are my 2. What is the difference, here's my question, in cost between single cans of soda from each of the 2 packs? What is the difference between 27 cents and 33 cents? What? It's how much? 27 to 33 is, oh wait, Zach, we're finding the difference. How much was it? 6 cents. Good. is 6 cents. All right, Mr. Steiner needs to purchase 60 AA batteries. A nearby store sells a 20-pack of AA batteries for $12.49 and a 12-pack of the same batteries for $7.20. Would it be less expensive for Mr. Steiner to purchase the batteries in the 20 or 12 packs? You know what, guys? I'm going to let you do this. Yes. And then one of you can come up and show us. Look, you have about 3 minutes, and then I'll call somebody to come up. All right, because we've done this over and over, and I feel like it's time for you to show us what you can do. Okay? So you need to set it up. It's just like the one we just did. Okay, let's see what we've got. We'll look back. Okay. We've got several different examples. You're going to set it up the same way.
Oh.
Yeah.
Oh, I thought that was the problem.
No.
Okay. Whoa.
I was just showing you what we've already done. So yes, do you want to do the first one? Okay, Mary, come up. All right, which one do you want to do? Which is the what? The 20 pack for $12.49. Okay. Okay. She's going to show us how she set up the 20 pack at $12.49. Okay. Good. Nice. Good, so she's going to one, yep, one individual, all right. Lots, good. Nice. So she's going to take $12.49 and divide it by 20. Yes, Courtney. No. It wouldn't make it a negative. It would make it 6. Yeah, it's not going to divide evenly with dollars. It's going to break it down to the cents.
Like, this is how I do it.
You did times. Okay, so while Mary is working, guys, Courtney's saying, look, he needs 60 batteries. I just multiplied. Is that what I'm hearing?
Yeah.
Yeah, to see which one is the better deal. So it's going to be 3 packs of 20. 3 times $12.49, get that amount, right? 5 times 12, that's 60. And then 5 times $7.20, which is the better buy? Because Mr. Steiner needs 60 batteries. You can do it that way and compare the two, okay? Because he needs 60 batteries. But, Mary, break it down. What did you get?
I got 62 for the remainder of 9. So my question is, would I round that to the nearest 10 and add it as a 63?
Okay, so what would happen is 20 can't go into 9, so you'd have to add that 0, right? And a 0 here and bring down, so you would have 90. So now, does that help you? So how many cents? 62 cents, right?
Yeah.
So put your decimal. Yep. Good. Nice. Okay, so 62 cents per pack. Or for one? The both of us.
I got the second
No.
Aw. I got
Okay, thank you. Good job, Mary. What did we get on the 12 pack? Did anybody do that?
Yes.
What did you get, Courtney?
I got. Yeah, it's probably good.
How many six?
Huh? How many? No.
What'd you get?
Oh, I got 66.
So he got 66. So the 20 pack was better.